Okay.
Okay, so you follow me. All right. Well, first of all, I want to thank you all, and actually I want to thank you all for some of the questions that I've been having with the technology integration and the pieces. You all are answering those questions today through your presentations. So I appreciate that. Just a little bit about our summer institute. We had it kind of turn on its side this year because I needed to have some surgery, and I had a hernia operation during the summer. So I have to thank my team here because they put up with me and my jammies and on painkillers for a good choice of ours. So I'm not sure about the data, but at least the part that I contributed. But I was on some painkillers there during that, but we did get through it. So thank you all for your.
He's off the painkillers now.
You should have told me.
So we take, right?
I think so. I do feel really good. So anyway, what the pieces we're doing, we're all going to contribute sort of the areas that we participated in. We've cut up sections that we have delivered this year, and we've done them not independently, but we're going to give our own presentations here. So first of all, some of the activities we did during the summer institute is we building the transfer relationships with community college. And you know, when we first started the PROPEL thing, I thought, what great opportunities. And I think we'd always had really great successes with our community college partner anyway. But I thought this was going to be pretty static. We could go in there and we could plug out these classes and we would have this done. This has been, with the changing in the community college and what we're doing and CCHE changes, it's been this target that we're trying to hit, and I'm not sure we're ever going to get there, but it's just the moving of trying to get that flow between the institutes. But what does help is that we've become phone call partners, email partners, right away we can call each other and see what's happening at all the levels. So that's been a really great relationship. The integration of technology and relevant equipment, and I'm going to talk a little bit today about a piece we were actually fortunate through the PROPEL grant now to get some equipment, and we got some new GPS equipment this year that we're going to use within the surveying industry. And that's the part I did a little bit on this summer, and now I'm perplexed with integration of this in the classroom. And I've been doing this for a while. I'll explain that as we go along. And then we're going to talk about some of the integrations within the curriculum and the new technologies. I'm going to start with the GPS part of that. And for those of you who don't know, global positioning systems, basically, we're using some of the surveying. We actually have survey grade GPS equipment that has the ability to use satellite technology, and we're able to collect data. And I see this as sort of a new technology in my profession. I'm licensed in multiple states as a professional surveyor, and this has been the revolutionary part of our industry where we went to this technology for collection of data. And to me, I think of it as new, but I look back and I think I've been doing this for like 15 years now, 15 to 20 years, so it's really not that new. But what I did find with the new technology is it's gotten so simple. I have to tell a little story, is that I remember in high school I took a photography class, and we learned about f-stops and light meter readings and all of these things. And now my phone does way more than I ever did, and we didn't have a class on that or anything. So that's kind of the way the GPS has taken over. So I have this dilemma now, is how much of that background knowledge do I have to let the students know? And do they really need it anymore? Do they just need to operate and go? So, and that's kind of the dilemma I'm having along the way. But I want to talk about, there's a couple of ways that we've been doing GPS technology. When it first came out, we did static observation. Static observation meant that we would put the information up, we would put the devices up, we would collect data, then we would take and post-process that data and come up with, analyze our solutions. And then real-time kinematic is where we were actually headed for when the technology sort of came out, is that we could get the data real-time. Now with technology out there, it is just, there's almost no reason for static observation. So I'm sort of, so to tell you a little bit about what we're doing, this is kind of the one of the beauties of what PROPEL has helped this institution help is giving us the opportunity to have more equipment so the students can actually use it. This is our older equipment, not the new equipment. I don't have the new pictures of our new equipment, but our old equipment, and we only had the ability to have two systems. So basically, we could have 2 groups. So in a 30-person surveying class, we had 15 people gathering around a GPS unit. Where now we're able to cut that down to about. Now we're going to be able to do about 6 units in a classroom, 6 to almost as many as 8. So it's really nice. We're going to be able to use smaller groups in using this. But a little bit about the RTK technology. The RTK technology. This is what I went over with my group, and I'm not going to explain to any of you all about the GPS, the science behind it, or any of that stuff. But basically, I would talk about the RTK technology. And RTK technology means that we can actually using satellite technology, we can actually gather the location of a point, a physical location of a point on the face of the earth. Well, your cell phone does that too right now. But the question is how accurate are we doing that? Well, the manufacturers of this equipment are saying we get sub-millimeter accuracy. Well, part of me says they're full of crap, because we have human beings doing that, and they're much more inaccurate than sub-millimeter accuracy. But if you take the human element out of it, that probably does exist. But the beauty of it now is that we can use the RTK, which is real-time kinematic data, and send signals back using radio frequency. And basically the process works as if we know the location of a place on the face of the earth, and we can put that information into the collector can then determine the correction factors for that, and then by using radio signal we can actually send those corrections out, and then any of the other datas that are communicating with that basic unit now have that sub-millimeter or that RTK technology, that real-time kinematic data, and actually we have that accuracy that's being broadcast. So it's really cool. So now I can set up a base station. I put 7 students with rovers, and they're all out collecting data that's really extremely accurate. So, question. Oh, sorry about that.
No, you were good.
Okay.
Put that around you.
So, just a little bit about what we're doing. What we've come to is what should we teach? And we've been talking about this. Jamie has the opportunity to get some GPS equipment at Pueblo Community College also. So we're saying, what is it that our students need now? And that's really the question we're having right now, and I'm having. So I've went through tremendous amounts of slides and presentations about the how-to and the science behind all of this. But sort of come to the conclusion is looking at our industry partners, and what do our industry partners want? And took a hard look at that. Our industry partners really don't care about this. I hate to say it, but they're not caring about all of the how do we get to the answer. They want to know the answer. So one of the problems that I've had is I'm the old dog, and I don't want to give away all of this so that we could train them to be users of just users of the data. So I'm looking at technology to maybe integrate video clips and some of the things we talked about, the pre-lecture slides, and maybe the pre-lecture videos that I think will be really good things that we can maybe package and then give those to the students prior to the lecture. And Jamie was looking for some of that and saying that as she grooms the surveying instructors at the community college who will come into our curriculum to have sort of those similar skill sets. So that's kind of what the dilemma I have had, and I went over my team and showed them all about how GPS works and everything during the summer. But really, this is what we're coming up with the GPS data, and it's nothing more than a coordinates on a grid. And all of that technology gets us into sort of a solution. And here's really the technology behind it, or the science behind it. Basically, we're taking spherical coordinate data that's collected, and converting it into rectangular or Cartesian coordinate plane and being able to use that data. That's really what the technology does, and it's just phenomenal how fast we can gather that. So the question is, what are we using the data for? Well, here's what my industry partners are saying. We're doing hydrological modeling. We're doing layout of control points, and I have to tell you a little story. We're sitting in this room, this building right now. We have students who work this year, and I had an electrical company came to me and said, we hired engineering students and students with your background, surveying students, to do the layout of this building. And the electrician who did this building told me his dad owned the company that they actually did, the electrical company. He's taken it over. How they would lay out this building when this was a concrete slab on this floor, the old way is they would come through here and they would snap some lines on the floor of this thing, usually in a grid system, and then all of these technology connections that you see here, they would mark those out on the concrete floor. And then they would say, eventually, that's where you're gonna, this is gonna set, and that's gonna set, and that's gonna set. His dad used to chalk a line down one line, chalk a line down the other, and they would do all their layout using right angles off of that. He brought a crew in. They sat with the GPS technology on the top of them where they could see. This was before there was a roof on it. GPS out here on top. Had all the coordinates for all of these things laid out in three-dimensional, and they went around and they set the points. His dad said where they would lay out 20, 30 points in a day, they laid out 300 or 400 points on the floor. Colored lines and dots everywhere in this building. And then someone came back and built. They even went as far as modularized construction so that they could just take a piece that was pre-built somewhere else and just clip it in right here to put this together. So that's where we're going with the technology. So our problem now is, how much of this do we teach to the students? Do we teach them the end part, or all of the science that gets there? So I think a lot of the technology I've heard today, or a lot of the use of technology we guys are using, the Camtasia and some of the other parts, I'm taking away from that today, just to say, maybe I need to put those little clips in there. So anyway, this is what we had a chance to go over. I explained to everyone how GPS works. The last part of this is something that I have been struggling with as an instructor within the surveying aspects of it. So really, this is what I'm beginning to teach my students, is that it's all about what kind of data do we put out, and is it reliable? Are we confident with the results? And I think all of you are saying that same thing, and about the precise. So the GPS piece of it was a great opportunity to teach my colleagues about something that I do. Also, I want to invite any of you who may want to get a chance to use that in your classrooms or something like that, wants to come in and show us a little bit of that. I want to invite that. Also get the opportunity is with the purchase of the equipment, we have a salesman coming in, and I'm going to have an opportunity to have the manufacturer give us kind of the presentation. We have 2 days coming up. If anybody's interested in sitting in for part of that day, or I'm going to try to do a general session and then a very technical session across the course of the days. But if anybody's interested in going to sort of the general session and understanding how the equipment is, I invite you all to do that. So that's not the spiel that I did and the piece that I did, but now I want to turn it over to my colleagues.
I'm Jamie Gage, and I'm from Pueblo Community College, and thank you all for making me feel at home by sitting in the back. With the GPS and all the surveying that we did, our department had bought a GPS surveying equipment exactly like what we worked on this summer, but we bought it used from another community college, and we received it half in a car from somebody, and something from UPS, and something got FedExed, and we got extra this and that. And so now I know, thanks to the summer experience that we had, that I actually have a complete set, which is really kind of cool. So I'm really excited about that. We're ready to break it out and get it to work. As Mike said, it's been a moving target as far as our articulation or any sort of transfer agreement that we've got. 2 years ago when I came on as department chair, 75% of our curriculum had been taken out at the state level. So we had to rebuild our curriculum using a class from this part and a class from that part to get it back together again. And we're getting really, really close. Now we're kind of refining and polishing as far as how we want to maximize the community college credits here at CSUP. We do have a limit on what will be accepted here in the amount of credits. Plus, at the state level, we also have pressure to say if it's a 2-year degree, it's a 2-year degree. It's not a 3.5 or a 2.5 and that sort of thing. So the pressure is to reduce and maximize what we offer, so financial aid's not in jeopardy, so that they're not paying for unnecessary credits. But yet, we still have to make that degree good at a 2-year. So what does a 2-year civil engineering technologist look like compared to the 4-year? So that's been a lot of the discussions that we've had. And so with that, we've tried to make a more streamlined transfer process for the students. We've had a lot of discussion on what does our 60 credits look like compared to CSUP. What can we give up and not diminish at our 2-year level, so that we are more in sync and our transfer rates are better. We end up losing our students probably on their 3rd semester because they realize that 60 credits are going to transfer. We have 73 in our program, and I don't blame them. Honestly, it's hard to argue that 13 credits you're going to pay for aren't going to transfer and aren't going to be valued. And so we decided that what we need to do is, our statics and our strengths and materials are always a problem. I don't know if you guys have the luxury, you probably have a little more luxury of being able to develop a cohort than the community college does. The community college, we have 16-year-olds and we have 80-year-olds in our program and everything in between. And of course, with those different ages are different problems, daycare, only night classes. I'm only going to take 6 credits this semester. I'm going to take 18. We don't have that nice 16 credit cohort or whatever every single semester. So developing a cohort at the community college level is extremely challenging. And then it gets more challenging as the semesters stack up. So statics and strengths and materials are our very last classes and are very difficult. We got to talking this summer and we said, well, it's kind of ridiculous that we're both looking for adjunct instructors to teach the same thing. That will eventually transfer anyway. And my classes are 4 or 5 students and CSUPs are much larger. And I know there is some disadvantages to larger classrooms, but there are definite disadvantages to 3, 4, 5 student classrooms. So this year I'm going to propose that we give up the 6 credits and let them transfer to CSUP and continue with statics and strengths and materials here instead of at our campus, so that we can reduce our credit offering. We'd also like to add more electives in and clump the electives where you choose 1, choose 3, so that if they eventually decide civil engineering technologies is not where they need to go, or if they want to go into the construction management, we can go ahead and target which pathway that they're going to do. And so that will help with our retention. That will help with our 2-year commitment. I don't think it's going to compromise their jobs at the 2-year level, because at the 2-year level there's support. Survey technicians, draftsmen, that sort of thing. So that's something to discuss further with our advisory committee, but that's what we're going to continue to work on. And so hopefully we'll be able to rebuild our program, make it look like something viable in the community that is sought after, and yet continue to increase our transfer rates and our retention rates here to CSU Pueblo.
Thanks. Okay. So I'm Daniel Trujillo, and I teach construction management and civil engineering technology. And part of what Jamie and I did this summer was go and kind of map out in our syllabus sustainable topics into the course. We use course objectives, modules, module outcomes, and directed it that way. So this is our syllabus. This is CT 207, construction materials and methods. It's a core class for both the construction management students and for the civil engineering technology students as well. So here's a picture of the syllabus. I make everyone read it, so I'm making you read it. But here are our course learning outcomes, which we all know. You take them to the CAP board and you say these are the course learning outcomes that we want. So analyze foundation types, compare and contrast different masonry products, define various metals used in the construction industry, and the goal is to interweave sustainability into these course objectives. So the first thing we did is kind of go in, map out the course outcomes, and then direct those. So these are our CT 207 course outcomes. And I've got them coded CT 207 CO1. So this is my course outcome number 1, analyze the foundation types and their uses. Course outcome 2, compare and contrast different masonry products and their uses in the construction industry.
I'd like to just chime in a little bit saying that we, Jamie, actually at the community college, we have a class that's, they don't call it CT 207, but it's exactly like this. So the
We spent,
make sure they're doing the exact same thing with their prefix.
So we spent a day kind of aligning these.
And assessing the same things as well. Yeah.
So so I'm aligning we're aligning our course outcomes over here to module outcomes. So we've taken kind of all the course content we want throughout the semester and put it in modules. Also, we're kind of aligning with Bloom's taxonomy levels of what we're trying to reach. In this class it's introductory, so 2, 3s, an occasional 4, 5, 6 on Bloom's taxonomy. So describe impact of buildings on the environment is one of our kind of sustainability aligned module outcomes. Recognize sustainable building practices, that's another module alignment. So those both align with our initial, I feel lost now. With our initial course outcomes, 10 and 11. So define, analyze, and develop construction plans, the analysis, a higher level on Bloom's taxonomy. So basically just kind of then go and align it to the content within each module. So making sure that we're aligning with our module outcome number 2, which is recognize sustainable building practices. In here you can see I'm hitting that module outcome here, codes and standards for sustainability in concrete. And then the text that we're using is, from the 5th edition to the 6th edition, has been an amazing difference in terms of their attention to sustainability. I mean, I think we have like 3 pages, and then we have, in the first chapter, probably 26 pages addressing construction and or materials, methods of sustainable building, etc. So, so this is kind of what we did, and with the readings, clearly we meet a lot of our module outcomes. So, the goal is to hit all of our courses and align sustainability into our course outcomes, module outcomes, and the course objectives. So, any questions?
And at our level, to be able to compare our assessment with CSUP's assessment, it's going to be really powerful on the sustainability piece.
A question for Jamie about those 13 credit hours and then the 6 that you're going to let them take over here. They can back transfer and
They can, they're not good about it.
they don't bother to do that.
Right, so we have to hunt them down, or somewhere they disappear, we lose them, and I mean, it's really logistically complicated. Yes, definitely, that's what we've been doing, but, I think the statics and the strengths and materials can be handled very adequately here without hurting our two-year terminal intent.
So I'm curious when it comes to actually careers and connections to the industries in the area. What is that? If it's a terminal, 2-year, what are the job opportunities really great? Or
That's
are
the
they-
discussions we've been having with our advisory committee, and it's diminishing, because now, engineers are even going towards a master's level and that sort of thing. Still, it's a support role, so the way I explain it to students is, do you want to create the ideas, or do you want to help the ideas come into creation? And that's the difference, I think, basically, and I hope you guys agree. But the support is helping engineers' ideas come to process, and the engineers are the ideas. So that's simplified, extremely basic, but that helps the student understand in a emotional sense where they want to be, and if they'll be happy with the 2-year as compared to the 4. So, and now that I know you guys have a minor in sustainability, maybe you'll accept more of my credits. Toward that.
So Mike and I have talked about this a bit, and I just wanted to alert the PROPEL staff to something that we're whining about, which is the new rules on field trips. Have you seen this? This is going to considerably limit how many field trips we take our classes on. We have a huge amount of paperwork that now has to be completed.
So, I sent Dave Lundpool to talk to Jonna about it,
Good.
and Jonna talked to Geraldine. And so now it's okay to have a single form for the semester. You just have to put the dates of your trip on it and your class roster, and you're good to go. Thank you.
That's good.
We don't need to get all the students to.
You gotta get it signed the very first day of the semester, but it's good for the semester. As long as you put the dates of each trip on the one form. Does that make sense?
I think this is good. I mean, strong.
It's better, it's better.
It's better, it's better.
It's a quick
What do you think?
resolution compared to some other.
Because we
what are
send
they
out,
gonna
we do a
tell us
lot
this?
of trips.
This is management by rumor again. What are they gonna tell us?
That's a great, so I said, when I got the email, I just like, Dave, we can't handle that. And Janet didn't even know about the form. So then when she talked to Geraldine, it got handled. It's a state form, so this is being pushed down from the state for risk assessment, risk management.
So if I email Denise, maybe I can get some information.
Let me send you the email that I got from John and Geraldine.
Send it to all the chairs.
Sure.
Yeah. Thank you. Okay.
Thank you.
Damn, I missed a good opportunity to line there.
Yeah, we still.
Okay, well, thank you very
Any other
much.
questions? Thank you all.
Okay, biology.
Me.
Yeah.
Aimed on a low point.